Okay, cool. So I think the session is recording right now. So yeah, so I just want to say good morning, afternoon, evening, wherever you may be in the world. I am some of you probably already know me, whether it be from the Messenger group chat, the Discord, or the WeChat group chats. But yeah, I am Pascal, um, the one who sort of got this whole review session together. So the plan here, as I have reiterated to everyone in this room, the plan is no plan per se. Given that we do not have a question, FSG question bank, nor do we um, what was I going to say? Sorry, I'm at a loss for words. Nor do we have nor do we have screenshots of the of the module questions. So I was thinking maybe we take this a little bit more low key, and maybe we will just go skim through the slides really quickly, and then maybe skim through some of the module notes. I also understand that Professor Isles has put some um, questions in his intro to week 4 slide, so we will certainly look at that as well. And yeah, with that said, I will now share my screen, and yeah, okay, so yeah, let me share my screen now. Sorry. Okay, cool. So I'm assuming all of you guys here can see my screen, which is my EESA06 folder in my Google Drive. So yeah, so I guess we'll go to lecture slides right now, and we will go into lecture 1. All right, so yeah, so I guess this is just really the intro. There's nothing too fancy here. He went over some important course themes. Yeah, namely plate tectonics, history of the Earth, rocks and minerals, geologic time, and then the geological history of Canada, and also the province of Ontario, and then just really the Anthropocene, some of the natural hazards and man-made hazards that we are facing today. So I think I can't exactly recall how many of these points we have gone over, but yeah. So important course themes. Let's see, what is he talking about here? So I guess there's nothing really too fancy here. He's just showing the continents coming. And he also made a point that the next, 2.5 billion years or so, they're likely to come back. They're likely going to converge together as they once did in Pangaea, Laurasia, Gondwana, yada yada yada. Yeah, something tap C. Guide to the Future. All right. Yeah. So then this is just more general stuff. What he's going to show off. Showing that there's a lot of there's plate tectonics, core, and let me see. Yeah, so remember how there's basically these hot spots, and these hot spots are are stationary. However, the plates they keep on diverging. Yeah, I don't know. Yay, magma. Um, Yeah, okay, cool. I'm just gonna keep on going. What's he showing? I think this is just like a map showing the trajectory, so on and so forth of all of the different sorry, of all of the different like plate tectonics where they're all headed. And if I'm not mistaken, I think they're all like converging like somewhere where present day China, Japan, Korea is. Is that correct? Can someone Oops. Can someone confirm that in the chat, please? Yeah, the hotspots never move. Correct. To my understanding, anyways, they don't. Yeah. So, and as you can see right here, the plate tectonics, they are converging again to present day China, Korea, Japan, basically present day East Asia, Southeast Asia. Yes. Okay. Yep. Next supercontinent will be in China. That is exactly correct, Kyle. All right. So, what is this? This is, I think, I forgot if this mountain had a name. This might be Mount McKinley. I'm not exactly sure. But yeah, a mountain in southern Alaska. Yay! New Mexico. I've never been to that state. I would like to go to the Southwest U.S. one day, but I have just never found the need to or anything like that. All right, moving on. I don't know, something cool rocks. Yay. uh, no, New Mexico. Here, let me pull up a here. I'll show you on Google Maps. I definitely should have prepared. All right, so let's take our happy asses to New Mexico. New Mexico. Yeah, so New Mexico is this state right here. As you can see, pretty close to Mexico. Somewhere around here, we have also Utah, Arizona. There is Texas experiencing quite an unfortunate turn of events in the past week. Yeah, California. So, anyways, yeah. So New Mexico is right here, middle of the desert. Yeah, lots of cool rocks. All right, so we will take. Yeah, so back to the slides. Let's see, Zion. I believe this is somewhere in Arizona, New Mexico. That general region in North America as well. Oh, I forgot where this is specifically, but probably no need to know that. I think what he's just showing here is these are different geologists. They are examining the sheets, right, of the different rock layers. And when they examine the surface, they're able to learn more about it. I'm pretty sure this image came up in the module as well. Yeah. Let's see, showing sedimentary structures. If you all remember from elementary school, middle school, or junior high, and high school, so primary, secondary school, you probably remember that sedimentary rocks are made up of a lot of fossils, and in general, they're much more made of fossilized natural material when you compare that to, say, igneous or metamorphic rock. So yeah, so it's just showing here that sedimentary structures, different layers. Yeah. Let's see. Professor Isles looking pretty sexy with his index fossils. All right. Let's see. So we have some trace fossils. And if I'm not mistaken, this is supposed to give us evidence that Pangea did indeed once exist, and as well as the Laurasia and Gondwana. Yeah. Coolio. So yeah, so I think that's what trace fossils are. They're just a form of evidence of the sorry guys, I'm totally blanking. Of yeah, plate tectonic activity. Pangea, yes, Pangea. Pangea is just a supercontinent. Yeah, I mean, yeah, it was that big supercontinent. If you guys are really into paleontology, dinosaurs, so on and so forth, this might already be prior knowledge coming into university. All right, cool. So then, yeah, geophysics. You got to play with these cool gadgets if you ever go into the environmental physics program. Yeah, I don't know, something radars. Yay. Yeah, looking at the different structures, different beds of the rocks, showing on the different layers. Nothing new here. Just showing a time scale. Let's see, North America. Uniformitarianism. Present is the key to the past. Yeah, so as you can see, this is the North American plate. I don't remember. Yeah, and then there's all these different things here. I don't think you need to know this whole legend. That would be completely ridiculous, anyways, for a bird course. Yeah. All right. The take home message of this slide is just this uniformitarianism. The present is the key to the past. Yeah. Promoting environmental geoscience specialists. Yeah, so then it's just showing like the different rocks coming into the that formed the different supercontinents. I honestly forgot what this slide is. All right. Yeah, so this is all very, 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 very broad. What do you mean where is glacial? Oh, what I'm glacial. Glacier, so remind me, are you okay? So glaciers are, you're right. During the ice age, glaciers are these really, really big ice sheets that came down. They covered basically, for the most part, the northern half of North America, as well as I think all of Russia. Basically, yeah, they in the ice age, they came down really, really, really far. And then that, had a lot of other implications as well, such as changing climate, so on and so forth, that you really don't need to know for this course. But then basically, I think about, if I'm not mistaken, about, 10,000 years ago, they completely receded, and they left behind all of these formations. So fun fact, I don't know if he mentioned this, but the Great Lakes are a result of glacial activity. All right, cool. Yeah, so he's just showing here what Ontario looked like 440 million years ago. Part of the Pangea supercontinent. Yeah, I don't know what that is. Whatever. All right. So then we have a subduction zone. Um, yeah, basically one plate sliding underneath the other. Yeah, so this is just one example of a subduction zone. All right. Yeah, so just showing it in another diagram. Scuba diving. I don't know, somewhere in the Caribbean. Yeah, volcanoes. Let me see. Um, I don't exactly remember what this is. Um, someone who watched the lecture maybe has their notes in front of them. Maybe want to explain what this is. No one? Okay. I don't know. This is just some place, I think, there's something geologically significant. I don't exactly remember. Sorry. Yeah, so in Canada, as you can see, there's a big ice sheet north. So this answers your question. There's basically a big glacier that came down. It covered all of Canada, and the northern half of the US. And then it completely receded 10,000 years ago. And yeah, volcanic rock. Yes. Oh, sorry. You're saying this Plymouth pictures is volcanic rock, Chenny? Okay, yeah, cool. So yeah, studying volcanic activity here, I suppose. Yeah, so glaciers. Today you can see glaciers in Northwest Territories, Nunavut, Yukon, uh, where else? Oh, Alaska, Greenland, Iceland, yeah, or no, not Iceland, Greenland. And then if you're brave enough to go to Russia, Siberia, those also have glaciers and so on and so forth. Ice sheets, basically. And yes, you can see the trails left behind. Um, yes, all right, so glaciers, I don't know where those is taken, maybe Alaska, Greenland, somewhere. And then, yeah, there's just mapping them. Um, and then, yeah, so there's the Canadian Shield. It's basically a big frontier, I think, if I'm not mistaken. Yeah. All right, so then Anthropocene, basically, um, showing here how humans have basically industrialized the whole planet, polluted it, and then in turn they have altered the climate at very unnatural rates. They have basically accelerated climate change. EESA01 people. This should be prior knowledge, so I won't really go too in depth into this. This will be covered later. Yeah, Scarborough. Um, yeah, so then my study EESA06. Just some motivations. This coupled with EASE-AO1. Um, yeah, so these are all the reasons. So um, if you don't like discourse as much, I do strongly suggest you do take EASE-AO1, as I personally found it was more interesting. Other people in this call could probably attest to that. Yeah. All right. So then, yeah, the Great Lakes are an area of concern. um, for ecological reasons, environmental reasons, climate reasons, so on and so forth. I think one of the master students went to the Congo, started analyzing mineral resources. Yeah, just another picture of that. Favorite road sign. He's in Death Valley, Route 66. Another picture of New Mexico. That picture again. All right, yeah. Get the textbook, or no, actually don't. Um, if you're in Toronto, I suppose you can get it. But there's no urgency to get this. This is just a documentary. All the links are on Quirkus. Filming, and use an app. Oh, so this is Niagara Falls. If you guys have never seen it, it's along the New York Ontario border. If you guys ever want to go there, I think it's about an hour and a half, 2 hours away from the Scarborough campus. Yeah. Yeah, I don't know. I think this is like somewhere along that border as well. Scarborough Bluffs is like what I think like half an hour or so away. Yeah. All right, cool. So then we have all of these things, yada yada yada. Um, and then this is a prereq for these two courses right here, Earth History and EC16 and DL07, I think that says. Yeah, all right. They went to a lot of places. Yeah. Take notes. I know not everyone has, and I have been providing all of the module notes. Yeah, okay, cool. So I guess with that said and done, let's move on to something a little bit more in depth, module lecture 2. So lecture 2 was basically a big timeline about the history of the discipline of geology. Um, and yeah, and how they were able to study it. This corresponds very, very heavily with module 1. So yeah, so let's just get into it. So this is an old atlas map of the world. Yeah, and then this is what they thought it looked like. All right. So yeah, so I think what I mainly got out of it was this idea that the Americans strongly believed in this permanentalism, permanentism, sorry, which basically states that the continents are stationary, and they cannot move. However, various different Americans, different geologists, and I think the Europeans and like basically everyone but the Canadians, they embraced this idea of mobilism, which basically states that plate tectonics are not stationary, but rather they move. Yeah, so then Alfred Wagner I think he published a book or some paper, some shit about it. Um, yeah, and then he was the one that came up with the idea of the theory of Pangea, which means all the lands. Yeah. Okay. And then yeah, we have so this was proven Pangea, the existence of Pangea was proven by the rock types. And it was also proven by remember those different trace fossils. So the trace fossils, they're showing up in different places. All right. Yeah. So then this whole idea of mobilism sort of transcended, transformed. I don't know what the word is, but it basically evolved into this theory of continental drift, and very negative perception, as it was invented by Germans during World War One. You guys probably know where this would go. So yeah, so basically the idea of permanentism still prevailed. Um, yeah, so then what is he just showing here? I think this is just like the different plates moving. It's rising and it's cool. It's rising as it's warming. It's cooling as it comes down. Um, yeah, and then I think they invented sonar or something like that. In response to detecting Soviet submarines or something like that, German U-boats and stuff like that. Someone correct me if I'm wrong. Am I correct? Okay, cool. Just someone let me know in the chat if I'm wrong about this, but basically utilizing essentially military technology to map out the ocean floor. All right, cool. Yeah, thanks. Yeah, so then it's just showing here the different methods in which they map the ocean floor. Yeah, so some of them you're able to refract to a hydrofoam, slough. I forgot what this was, honestly. Yes, sorry about that. But yeah, it's basically just a lot of different reflections. Yeah, magnometer. All right, so then once they basically mapped out the ocean floor, they basically found a lot of these mid-ocean ridges and these fractures and these trenches, and that's a lot of the sources of a lot of sources of volcanic activity, plate tectonic movement, so on and so forth. Yeah, cartoon. Yeah, so what is she showing here? I think this is just magma. There's yes, I believe so. Or was it mapping the ocean floor? I'm sorry, guys. I'm totally like losing it. Yeah, it might be both. Yeah, sonar system. Yeah. Anyone else agree or disagree with? Yeah, anyone? Okay, cool. Um, yeah. So then I don't know. Magma. Yay, lots of magma. I think it was something about like it cooling or something like that. Um, Yeah, so north's both. Yeah, so as I was saying, magma, it's basically found at the, it's found in the intermantle and it comes up and it rises. And I think they were able to use this to, and I think some magnetic particles got trapped in the magma once it cooled, something like that, and then they were able to measure the magnetic field. So I think that's another use of the magnetometer. It was used to measure the direction of these magnetic particles in cooling lava or cool down lava. Yeah. All right. So what is this trying to show? Oh yeah. Okay. So I guess just further evidence that continental drift. Um. Yeah. So then what? So then they were able to reconstruct Pangea from all of the modern day countries and continents. Yeah. And then yeah, so then if you guys remember from I believe Cyber Module 2 or 3, that's the Mid-Atlantic Ridge is exposed on Iceland, which is this country right here. Um yeah, they were able to look at seafloor spreading. And yeah, this guy abandoned permanentism. Once he was able to see this and magnetic stripes, the different anomalies, if you guys remember that. Um, let me see, paleomagnetism. Basically, I think this is just showing that, yeah, so as it says here, the magnetic field flips, I think, every either million years, billion years, something like that. Yeah. Showing the magma picture again, more evidence. Yeah, so then changes through time. Sorry, my bad. 500,000 years. And then yeah, 10,000 years or less for a reversal to occur. So it wouldn't really be noticeable in our lifetime. We would be long dead. Yeah. All right, cool. So then I think these are just the different ages. Um, yeah, magnetic stripes, red mine. I don't know. This is Iceland. Yeah, and in Iceland they were able to use a GPS-like technology to measure. I think they were really studying the Mid-Atlantic Ridge and so on and so forth. Um, yeah, I don't know. Picture. uh, yeah, I don't know. He's in a BMW. Um, let me see. This is Tuzo, right? And he was the first. Geophysics student at UT, right? So I think this is who this is. Um, yeah, like mountains. They measured it. They were filming and stuff like that with this really sketchy camera concoction like thing. Um, yeah, and then um, yeah, different types of earthquakes. Um, segmented. So I think this is just him simplifying it, and just remember this paper model. If you guys want to make it yourself, maybe I'll try and make one before the review session next week. Yeah. So then, yeah. And then yeah, this is just all the plates together, and the outlines of all the plates. North American plate. Just remember that the coast of the North America as a continent is not the edge of the plate. The plate also encompasses half of the Atlantic Ocean, a little bit of Pacific, I don't think not much. Also a little bit of the Arctic Ocean up here. Even absorbs a little bit of Greenland. I think this is, a little bit of Siberia up here. Yeah, so North American plate. Remember, it's not the coast, it's this whole thing, this whole blob. I think he's just showing like the rate of the spread. And it's about the same as the growth of a fingernail annually. Yeah, so that's all that is. Drilling, they aren't able to drill very far, I think. Yeah, so this is the deepest that they've been able to drill it. In other words, they've not been able to drill, if I'm not mistaken, to the mantle and so on and so forth. So they have to use all this sonar technology to be able to do that. Yeah. Just the age of the ocean floors. Just remember, that the oldest rocks are generally pushed off more to the sides, and the newer rocks are more in the center. And who's that? Who just tried to join? Did anyone just try to join? Okay, never mind. Yeah. Then there's these hotspots, which further prove it. Remember, they're stationary, and most of them are situated as islands. So you can see Hawaii, Samoa, Galapagos, so on and so forth. The exception to this is mainly Yellowstone, I think is the one he emphasized, which is in Wyoming. It's, if I'm not mistaken, I think it's directly below Alberta or Saskatchewan. Yeah, this is relative to Canadian geography. So yeah, so Yellowstone in Wyoming, below Alberta, Saskatchewan. That was those provinces. Yeah. Volcano chain. Remember that they keep on getting pushed, and the active one is the one that's sitting directly above the hotspot. And they're able to track it, and it sort of flattens out more. It is, and then Hawaii. So this is the oldest island. The newest island is the big island is the newest island, or sorry, and then there's also one tiny baby island here, I think. Yeah. All right. Yeah, Wilson cycle, I think, is basically just showing that that the plates split and come together. Yeah, so then there's that picture again. Science Center. All right, cool. On to lecture 3. What was this one about? Oh, I think this is about the interior. And then about earthquakes and stuff like that, and PNS type systemic waves. I think this corresponds with module 2. So yeah, so he's just opening up with a picture of earthquakes. And then there's some terms here. So you have this focus here, epicenter, and then they kind of rub against each other almost, and that's what causes earthquakes. Yeah, so then all these epicenters, mainly centered around the borders of the plate tectonics. Yeah, I don't know. Then he's just showing more and more of that. Yeah, again, showing that continents are emitting larger tectonic plates, such as in North America. And yeah, I suppose you would need a key for this, to determine where the divergent margins transform and convergent margins, where all of these are. The hotspot thing again. Let me see if there's anything new. Plate kinematics, just a movement. China will be the next supercontinent. That picture again, Wilson cycle, drilling. Yeah, so converging all in the Sea of Japan, China, Korea, wherever, somewhere in East Asia will be the next supercontinent. Then he's just showing that there was a big earthquake in Japan, if I'm not mistaken. And this is what began the science of seismology. Yeah, coming apart. These are just different types of faults, showing that they can either compress together or they can diverge apart. Yeah, fault scrap, I don't know. This is just showing how a seismograph works. And then yeah, there's the Richter scale and moment magnitude. Yeah, so I think the main key here, just remember this magical number for Richter scale, 32 times. Yeah, and then it's just showing surface and yeah, some primary and secondary waves. I think, if I'm not mistaken, primary waves move faster, but they can only move around the plate. They can only move around the things, whereas the secondary plates they can go right through. If I want to correlate this with something, this reminded me a lot of when of bio AO2 when we were learning about plastic and symplastic movement of water or pressure of water. Which one is more dangerous? I forgot if we answered this question. I think it depended, right? Yeah, I forgot the answer to this question as well. Yeah. Anyway, so well, I guess surface waves are very destructive to buildings. Or this didn't really answer the question, did it? I think primary waves are primarily found on the surface. And secondary are like, yeah. Sorry, I again, I don't exactly. I think he also. I mean, even he also admitted that he doesn't really know the answer to this because it's relative. Yeah. Seismograph, seismogram. Sorry, just calculating all of them. Yeah. So then, as you can see, P wave, S wave. And I think S waves. Oh, I forgot what this showed. Could someone help me out here? What this showed? I think it's just showing that there's longer intervals the further it is. Yeah. Okay. And surface notes. Surface waves cause more. Okay. Yeah. Yeah. So then it's just remember you have a triangulation point to get the epicenter. So you need at least three different points. So it just happened to be here, triangulation. Yeah, so now you have the P waves, which just kind of graze off. They're not able to penetrate the core and the mantle, I think, if I'm not mistaken. Or maybe just not the core. But they're able to go right through. Or yeah, and then wait, what? Okay, yeah. Anyways, these are just different travel paths. Yeah, okay. Yes, that was primary waves, correct? Okay, cannot go through molten rock. Okay, yeah, okay. So yeah. So this is I remember this also came up in the module. So yes, the core is liquid. I think. I think it was specifically it was the inner core. And then I think the outer core was like solid or something, or it was the other way around. Yeah, something like that. Anyways, yeah, I don't know. Density, meteorites, Clodor past, yeah. And then they're able to create artificial earthquakes with these. Yeah, I don't know. Yeah, the lithospheric plates, they're able to slide across. Yeah, metamorphic rocks. Yeah, this is just heat flow measurement. I think spreading centers, plumes in the mantle. Yeah. All right. Yeah. So that's all that is. Lecture 4. Oh yes, it's about the East African Rift. All right. So Nora said that the temperature of the inner core is far above melting point of iron. However, unlike the outer core, the inner core is not liquid or even. Yes. Yeah. So I think, yeah, sorry. So I think inner core is more dense than outer core. So inner core is solid and outer core is liquid. Yeah, exactly. Okay, cool. Um, yeah, and no one really knows because no one has really been able to travel down to the core. Remember, the drills cannot the drills can only dig so deep. Yeah. Okay. Anyway, so East African Rift. I don't know. I feel like I'm repeating myself, but yeah. So let's just see if there's anything important. So then I don't know. So then that. Anything? Oh, okay. For people who were in EESA01, this will be an important slide. Just remember divergent boundaries is when they diverge or they come apart. So kind of like this, and we can see my hand movement. Conversion is when they come together, and then transform is when they slide past each other. So that's all that is to here. And then when ocean meets continental, they form subduction zones and conversion plates. And then when continent meets continent, they form mountains. So that's how you get places like Himalayas, Appalachian, Rocky Mountains, Andes. I'm blanking on probably like other ones, but yeah. So those are the main ones that I can think of off the top of my head. Yeah. Okay. I'm not gonna dwell on that too much. Just know. Rock cycle. Um, yeah. So then igneous rocks are from magma. Um, yeah, so then they can be extrusive from lava flows or intrusive. So like these dike layers, you can see, igneous rock has found itself into these rock formations, rock walls. Um, yeah, so then convergent margins, yeah, they're mainly, I think they're made out of andesite and granite. And then divergent boundaries are just basalt. Um, yeah, we can describe them by texture or chemical composition. Yeah. Um, yeah, this is the Wilson cycle again. Um, yeah, so this is divergent boundary. So it's just showing that the plates come further and further apart, and then as the things come apart, the water is able to come in. So at first it forms something like the Red Sea, and then it might form something like, say, the Atlantic Ocean. Um, yeah, continental shelves by rifting. So rifting is just, remember, very, very deep. Yeah, so then oil rigs are, yeah, so then rifts are just very, very deep pits, like kind of things that formed as a result of divergent boundaries. And then yeah, and then I don't know, oil rigs, I think. Prime hotspot for oil rigs and a lot of oil. So yeah, continental shelves. You can see it's all along here. New oceans. Oh yeah, so yeah, so so there's 3 points, triple junctions have 3 different arms. And then 2 of them are gonna form a big rift, and then one of them is not, and it's called the failed rift. Um yeah, so I don't know that word. Um yeah. And they're preserved as these things. Yeah, active margins, intraplates, Arctic, I don't know. Yeah. Yeah, so then East African Rift, nothing really. Yeah, so then I guess these things, there's highs and there's lows. Um, and then yeah, there's a new ocean floor crust made out of basalt. Yeah, right there. And then yeah, they went to Professor Isles. He visited a volcano, I think. This is his trip. Then remember then yeah, so then he's showing off the different forms of lava. Yeah, so it can be Palahoi or something like that. And then ropey, and then or A, I forgot. Yeah, so then remember he got kidnapped or snow, I don't know. Stratovolcanoes, ash layers, and then yeah, origin of mankind, Australopithecus, Homo habilis. Yeah. I don't know. I don't think that's the name. I don't think that's his bike. This is his bike. So this thing right here, is his bike. I believe Neil Patel, he warned us about this. If you're in the messenger group chat. Result of rifting or continental drifts. Um, I think it's just rifting because East African Rift. Yeah. Um, I forgot if the TAs are holding office hours about this. So yeah, so anything like even I'm not sure about, you can ask the TAs about. Um, yeah, so then I don't know. Artifacts, Red Sea, pushing the red plate, rifting and drifts. I think rifting is just splitting, and then drifts is kind of like general movement. Does that answer your question? I don't know. That makes sense, right? Yeah. Right. Okay. Then yeah, so it's showing the Red Sea. Da, 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 da. Yeah. So then remember he went to Petra because the East African Rift like ends somewhere in Turkey or somewhere. Um. Yeah. I don't know. Then yeah. So then I think this showed like there was like a uniform like rifting or something because they were all knocked down in exactly the same position. And Crusader Fortress, yeah. This wall was built in between two plates. Um, yeah, I don't seismic activity. A lot of earthquakes and stuff. I don't know. Yeah. Okay. Okay. Last lecture. For the midterm, anyways. Let's see if there's anything important. I think this is mainly about Iceland. Yeah, so remember they used the Alvin to explore all these deep sea thermal vents, hydrothermal vents. Yeah, yeah, so many earthquakes in Turkey. Yeah, so then just remember ophiolites are remnants of like ancient oceanic crust. I think the example he gave in Canada was Newfoundland is one of these, right? My memory serves me correct. Yeah, so then I don't know. Building onion model, there's pillow basalts and dikes. I forgot what these were exactly. Oh yeah, so pillow basalts at the surface, and then yeah, and then I think dikes more at the bottom maybe. Um, yeah, hotspots. I don't know. Then he went to Iceland, land of ice and fire. So I mean, these are all the hotspots here, or a fissure. Sorry. Um, yeah, and then he went to Iceland. Um, and they're able to measure, I think, the spreading. Yeah, nothing too new here, I don't think. Yeah, so then ridge jumping. Yeah, so that fissures. And then I think, yeah, they're just splitting. Yeah, so fissures are these like deep crevice things. And a lot of eruptions. I don't really know. Then he went. Yeah, somebody cited the first parliament. Yeah, so let me see. I don't think there's anything too new here. Oh, yeah, so then there are these floods. They're caused by volcanic eruptions. Yeah, so they're just showing here. There's a lava in the lake. Pillow basalt. He said you don't really need to know this, I think. And yeah, there's flat top Mogberg Mountains. I think they're called Tuyas in BC, so you're in Vancouver, somewhere around there. Yeah, so then and then what was it? I think it was like there are these big eruptions and they release a lot of sulfur and stuff in the air. And then all the crops and all the livestock dies out. So that's why you have like these big famines. And then this is what caused the French Revolution. Because all their crops were dead. And yeah, they also blamed it on yeah. Okay, anyways. This is not a history course. Yeah, tephra. Yeah, pillow basalt probably. Yeah, this is somewhere in Ontario. I think it's like a Icelandic ghost Canadian ghost town. Yeah, so then it's just a mini tephra thing from 2010. How to name a volcano, the cat or dog or whatever jumps on the computer. Yeah, then hydrothermal energy. Because of all these volcanic activity and fissures, so on and so forth, they're able to form these. They're able to utilize hydrothermal vents as a source of energy. Yeah. Okay. So that was the 5 lectures. I don't really think we need to go over the modules because those are essentially a repeat. So yeah. So let's go into intro lecture 4. And go down to the questions, so which are right here. Yeah, I don't really know what. Was there any burning questions that you had about this? Because I don't think I'll be able to answer this. This is my first time seeing this, and I have no idea what any of this means. Yeah. Oof. I don't either. Did he explain them in the intro lecture? Like the intro to week 4 lecture? Yeah. Okay. Let's see what. Okay, dog. I don't know any of these. Yeah, okay. I guess I know that and that. What the fuck is this? Okay, you know what? This is traumatizing me too much. I'm gonna. Yeah, okay, cool. I'm gonna stop sharing. What the fuck was that? Yeah, So, in other words, we're fucked. Yeah, I did a really poor job at explaining the 5 lectures. I don't even know if I'm gonna attempt to I'm gonna attempt. So I think what we should do. So I think at lecture 4, or sorry, not lecture 4, module 4, is coming out next week. As usual, I will get the slides out. I will send them out to all the group chats, Messenger, Discord, WeChat. Yeah, and yeah, I don't. How, so moral of the story, take EESA01 if this midterm goes south. You should still be able to get 50% of your of the 50% refund, because I took the Mat 830 midterm like around this time, and then got the mark back, and I was still able to nab a refund after I dropped it. Yeah, yeah, exactly. Yeah. So what I'm saying is, wait for the midterm, see what happens. And if you happen to do okay on it, I'd say it's not worth dropping. Because I'm gonna be honest with you. So in terms of like energy, expending energy, for a natural science credit, this is the least intensive, because even in EESA01 you will need to do labs, and get PPE. Um, yeah. So I'm gonna stop recording right now.